In this video we'll discuss tessellations. Now tessellations are a repeating pattern of figures that cover a plane. There can't be gaps or overlaps in those figures. So here's three examples. A brick wall. Here is a common pattern you may see on a floor with octagons and squares. And here's a pattern that's made up of all sorts of triangles placed together. Now there are two primary types we often talk about with tessellations, which are regular and semi-regular tessellations. A regular tessellation is made up of a single regular polygon, and this only works with three specific polygons: the regular triangle, in other words the equilateral equiangular triangle, a square, and a regular hexagon. Those are the three regular tessellations. And if you can see here, when they fit together perfectly, no gaps, no overlaps, to create almost like a grid or honeycomb type of picture. A semi-regular tessellation is made up of at least two regular polygons. So if I took any regular polygons and I used at least two, or three or four, however many you need, you could create a tiling. For example, that octagon and square tessellation from earlier, those are made with two regular polygons. Here we have ones made with a regular hexagon, a square, and a regular triangle. Now you can create tessellations that are not with regular shapes or regular figures. But if you talk about having a regular or semi-regular tessellation, these are the conditions. Now for any object to tessellate, where the objects come together has to sum to 360 degrees. So when we think about three hexagons coming together, each of those angles is 120 degrees. So 120 times 3 is 360. With the octagon and square picture, the interior angles of a regular octagon would be 135 degrees, whereas the square is 90 degrees. And if I add all three together, that's 360 degrees. Now there are four different ways that we can tessellate, and it's all based on the symmetry that we know can exist. So there's translation symmetry, reflection symmetry, rotation symmetry, and glide reflection symmetry. When we transform based on the symmetry, we have to make sure that those shapes are actually adjacent with no gaps or overlaps. So that is one of the distinctions from just having general symmetry. So if I look here, this looks like a crazy tessellation, but if I try to zoom in and look at three specific images, I can see that this is a rotational symmetry based tessellation. It's this weird looking image which is based on a hexagon that's been rotated to create all these images. Here we have the birds, and these birds are being reflected. If you look across here, they're being reflected horizontally and vertically, so that they're alternating patterns, and this is a reflection type of symmetry, and that's based on using a rectangle. Now to create a tessellation, you have to figure out the shape you want to start with, and typically we start with a shape that only needs a single tessellation, a triangle, parallelogram, or hexagon. We determine which of those four types of symmetry we want to follow, and then we start manipulating the original shape. So if I think about starting with a rectangle, if I want to do a translation, I could say, okay, I'm going to draw in this piece here. I would cut it, and I would shift it to the right. This will allow me to put the pieces together like a puzzle as a tessellation with the shift, just that translation going left to right. Now if I want to have, I could stack them like bricks, but if I wanted to add a little bit more design, I could always create a translation going vertically. So I would just take and cut that design and move it directly up. Now I could, if I really wanted to, create a translation going horizontally and a reflection going vertically. I would just take this piece and have to reflect it on this side. So I'd have to flip it around to create it. Now I can fit all of them together like puzzle pieces. I have my design and I can fit it all together, and there I have a tessellating image.